Yea, though I venture into the labyrinth of tubes and gears, I shall fear no misalignment, for my Allen keys are with me, my patience and discord, they guide me. Surely tangled filaments and sensor woes shall test me, but I shall emerge victorious. For in the house of multicolored prints, I shall dwell forever. So, I did it. After weeks, months, I honestly don't know how long, I finally got the ERCF V2 working. It wasn't easy. Like, it really, really wasn't easy. But between dogged perseverance, moral support on live streams from all of you, and the tremendous help of the ERCF Discord, we got there. So in this video, I want to document everything I learned along the way, what it took to actually get this thing working, and the answers to some of your most pressing questions so that A, you can decide if you really want to take this on as a challenge on your own, and B, if you do choose to take it on, you'll actually know how to overcome the hurdles that I had to overcome. Because apparently, according to people in the know, I unsurprisingly hit just about every single roadblock that a person could. For science, let's get after it. First, let's talk about all of the technical hurdles I faced and which you're unfortunately likely to face as well. As I alluded to in my previous video on the ERCF, link right here if you haven't yet seen it, one of the trickier parts of installing the ERCF is that you will likely want to upgrade the toolhead on your printer. Yes, you can get by without doing this, but to make your life a whole lot easier down the road, you will want to install one or even two filament sensors in the toolhead filament path, as well as add a filament cutter right on the toolhead to eliminate the need to perfectly tune the tips. Unfortunately, this is probably going to mean that you do need to change out the existing toolhead board to make room for the two additional micro switches on the actual toolhead board. And so, it's probably a good idea to take this opportunity to upgrade to CAN bus. I originally was going to try to make this work with a Big Tree Tech EBB36 because I hadn't yet received the LDO Motors Nighthawk stealth burner board, but the EBB36 is actually relatively sparse on extra GPIO ports, so I instead decided to use a spare MKS THR36 board that I had kicking around here. Now, I won't go into the procedure for flashing the board as there are tutorials out there for how to switch to CAN bus, but I will say that I did need to learn a fair bit more about CAN bus as a whole, as well as the parts of Klipper that I least enjoy and least understand, in order to get both this board and the ERCF's board communicating with the main board over CAN. This meant changing a whole lot of config files to map out all of the new pins and all of that, but eventually, by following all the different directions out there on GitHub, I got there. I also, after destroying 3 pricey Revo nozzles due to issues with homing, RIP, decided to take this opportunity to upgrade my probing solution to something very new and very exciting, but unfortunately, I'm actually not allowed to talk about that product yet, so just make sure that you're subscribed to learn more about that in a couple of weeks when I'm actually allowed to talk about it. The next thing I should have done was upgrade KlipperScreen to the ERCF compatible fork to test and see if it would even work. This is because if you're on an old version of Python and Raspbian like I was, there won't be any easy way to upgrade the Python libraries that KlipperScreen will use. Actually, upgrading Python won't do it. Long story short, you are going to need to flash a completely new SD card. In other words, you're going to need to set up the printer from scratch as if it were a new printer. Now, I'm really, really glad that members of the Discord Voron told me to flash a new SD card because that made it much easier to transfer over macros, config files, and even my history of past prints, though you should also make sure to use one of the various different backup solutions out there, such as clipperbackup.xyz, to make sure that you have everything completely backed up. But yeah, it will still take some time to reconfigure things the way that you like them, copy over all the config files, your print history, set things up the way you want them, and so on. Because, like I said, you are basically setting up a brand new printer. Then, once you've done all of that, you will be able to install the Happy Hare distro of KlipperScreen, which is important because it's going to make things much easier when you're testing and tuning things and you want access to those ERCF macros. Now, don't do what I did and put it off and say that you'll just live without KlipperScreen for a little while, because that also means that you won't have an emergency stop button for your printer, which means you can't do anything as you watch your toolhead crash into the bed and destroy your beautiful Revo nozzles. Ask me how I know. Once the printer works, you have the latest firmware and KlipperScreen, and all of the ports are correctly mapped to the new pins on the new toolhead board, it's time to install and configure Hare, the software that runs the ERCF. Now, this is pretty self-explanatory. There's an interactive prompt that actually asks you questions about your setup and then does everything for you in the background. There might be some things that it doesn't do quite right, like the order of the individually addressable LEDs, but for the most part, it will do a lot of it, and then later on, it even has a lot of automated macros for calibrating things like the distance between the two different toolhead sensors as well. So once you have Hare installed, you will start to see buttons with all of your toolheads right in mainsail, and eventually they'll even show the filament color that's loaded. And you'll be able to click each one of those buttons to load each toolhead once you go through all the calibrations. The other software side thing that you will need to do is update your slicer. When you install Hare, it overwrites and adds a bunch of macros, and now you will need to update the G-code that your slicer adds to the start, end, pause, and layer change macros, as well as a bunch of other stuff. You'll also need to add extruders, obviously, zero out a bunch of values, and basically just let Hare take care of everything without the slicer injecting any of its own G-code for tool changes. All of this is actually documented on the GitHub, so I won't do any tutorials for it here. Now, I know you're very excited to actually test this thing out, but take it from me and do yourself a favor. Please upgrade the servo your kit came with and just replace it with a better one before you start calibrating and tuning. Most of the kits out there, including the Physek one that I built, come with an MG90S servo. This is a piece of junk. It's not nearly strong enough to make it over the hump on the selector top hats, and even if it does, it will bounce back when it is overloaded, meaning that you won't be able to even grip the filament to begin with. Now, you can waste hours or days of your life trying to get the right amount of tension in the spring to get this to work, sanding down the arm and the top hats and all that, but ultimately, you probably won't have any luck with the MG90S, honestly. Unfortunately, the Savox servo that you need to upgrade this whole experience is $35, which is like 20% as much as the entire ERCF kit costs, but it's worth it. Once you install the Savox, all your issues with proper amount of pressure and filament slippage should mostly just go away. Now, just remember that you do need to print the correct servo arm and bracket, and you do need to update your config in the firmware when you switch to the Savox. In case your issues don't go away or you still have major slippage, you might need to reprint some parts such as the top hats to get better clearances. As ERCF team member Ivan Trail pointed out when he was kind enough to actually consult with me on this video script to benefit all of you, you really can't overstate how important print quality is when you're talking about printing the ERCF parts, especially for the filament blocks. They each need to close completely except for the magnets causing them to hover, and if there is any resistance to them closing except for that magnetic repulsion,
you're gonna have a bad time.
I had originally printed these top hats, so the overhangs and built-in supports weren't all that great, which meant that the alignment of the gears was not absolutely perfect. This one doesn't spin as nicely, but I think it'll be fine. Once I reprinted them all on a printer with much better cooling, in this case the Creality K1C with its auxiliary fan, the problems magically went away. I also do want to point out that part of the issue might have been that I printed all the different parts on many different printers to save time, so they probably didn't all have the exact same dimensions and proportions and all of that. Now at this point, you might be asking yourself, so wait, in addition to actually building and configuring this entire thing, I also need to build and configure an entire Voron? Well, actually, no, thanks to this video's sponsor, Servo. Servo makes a wide range of highly affordable Klipper-based open-source 3D printers, from the SV06 Klipper Edition to the SV07, SV07 Plus, and the new Core XY monster, the SV08. And because these printers, particularly the SV06 and SV08, are fully open source, all the way down to the actual CAD files, you can easily tweak and tune them, create your own versions of parts, or swap parts to another ecosystem entirely, such as the Stealth Burner Toolhead that most people choose to use with the ERCF. Heck, I'm actually about to start the process of converting my own SV08 into a 7 Toolchanger, a process that was made significantly easier thanks to the readily available CAD files. What's more, if you don't want to deal with actually building the entire ERCF, Servo will soon have a collaboration with CoPrint for a mostly plug-and-play multi-material system built around the SV08. I personally use and recommend Servo's products regularly, and I'm really grateful to have them as a sponsor. So to check out their full line of printers, filaments, and 3D printing accessories, please visit the link in the description or go to jle.vi/Servo today. The next thing that you're probably going to want to do is install and configure the filament cutter on the toolhead. Now you will need to mount that little pusher pin on the gantry and configure it in the firmware so that the firmware knows where it should go to cut the filament. Also, I recommend triple checking that both the hex nut and the PTF V-tube in the toolhead are chamfered, and that the hex nut is either glued down or sufficiently stuck in the plastic. Remember that from now on, the ERCF and the extruder are going to be the ones pushing in new filament, and they won't know to wiggle or turn the filament if it doesn't go in perfectly the first time. That'll save you a lot of errors, trust me. When you use the filament cutter, you eliminate a lot of the hassles of tuning the ERCF, but you still will need to do some auto configurations to figure out the distance between the sensors, as well as the distance that you can safely retract before cutting. By the way, I recommend using the remixed version of the lever arm, which includes a magnet, because it really helps the lever not get stuck. And if the lever gets stuck, it's going to block new filament from going in. I also chose a much stronger spring than the one included in the kit, and I even stuffed a bunch of M2 washers into the holes to add even more tension on that spring. Just keep in mind, each one of these little fixes that I'm sharing with you guys in this video is the result of literally hours and hours, or even days of testing and figuring out how to overcome specific problems that got me stuck for a long time. So if you appreciate me giving you the cheat sheet on this whole thing, don't forget to like and subscribe. The next quick fix that I needed to do was removing the spacers in the ERCT buffer between each of the wheels. Honestly, I'm not really sure why those are there. You don't actually need them, and once you remove them, the buffer wheels spin much more freely, which makes it so much easier to actually load and extrude the filament. I still need to actually get up on a step stool to load filament, and I'm working on a better solution for actually feeding the filament directly off of the rep rack so that there's even less friction, but at least it's easier to load it now. All right, now let's get to the part that I'm not so proud of. No matter what I did, I was getting an awful, horrible jams when the system tried to retract the filament. I don't know why it does that, and I wasn't sure why. Despite the fact that there are so many grub screws holding the D-rod in place, it was shifting, and then either the hobbed gears inside each of the selectors on the cartridges themselves, or the large CNC gear wheel was actually shaving against the plastic and getting completely jammed. So I tried a dozen times to relocate and realign the hobbed gears or add washers on the end and all of that. But eventually I got really tired of it constantly failing. So I sanded the ever-loving heck out of the bracket where the gear wheel is. And then I added not just a few washers, but a fat threaded insert as a spacer, and I just called it a day. Now it sometimes creaks, but it doesn't jam. Don't judge me. Hey, you made it. The mechanical parts are finally done, and you're now finally ready to calibrate a million different things in a frustrating rabbit hole that feels like it will never end. I'm joking, but seriously, there is a lot of stuff that needs to be calibrated before you actually even print something. For the most part, the Happy Hare wiki is your friend, and it will walk you through mostly step by step all the things that you need to calibrate. So follow that as closely as you can. For example, you'll need to calibrate the servo angles so that it knows what's up. No, I don't mean knows what's up. What's up at this point is that you're exhausted and you're just about ready to use this thing as target practice. I mean, what position is up, as well as what's down and what's a safe position for travel. You'll also need to calibrate the positions of the selectors, and potentially you'll then also want to customize the positions for some of the individual ones if, say, there's a small gap in between them. You'll need to calibrate the main drive gear so that it knows exactly how much to turn. And you'll need to calibrate the Bowden length so it knows how long to turn. You'll probably need to calibrate how much to pull the filament back before cutting it to minimize waste, and chances are if the different gates have different tolerances and different levels of slip, they will. You'll need to individually calibrate each of the gates and the gear for each of those so that the ERCF knows how to compensate for the varying levels of slippage on each one of them. And I'm sure that there is a whole lot of other stuff that I forgot to mention but ended up calibrating. It's a lot, but follow the guide, ask questions on Discord when you get stuck, and eventually you'll probably get there. By the way, this is probably also as good a time as any to give another huge shout out to the ERCF questions community on Discord, particularly Mark Norris, Ivan Trail or Silverback Attack, Justin R, and Dragon Kitty, who were all so helpful and so patient in answering my million or so questions, of which there were actually so many that I'm pretty sure Mark will legally be able to declare me as a dependent on his tax returns this year. At the end of all this calibrating, you're ready to cautiously, and without getting your hopes up, attempt some test prints. Things will go wrong. There will be blood and a lot of wasted filament. But in my experience, running test prints is just the fastest and best way to identify potential issues. You'll discover that some gates are slipping more than others, that sometimes the cutter misses its mark, that your filament has too much friction on the roller to actually unspool. And as you go along, you will then fix each of these issues individually until things slowly start to work. You'll also probably need to tune things like retraction, macros for filament swapping. I'm actually not even done with all of this myself, but I am at the point where I can get filament swapping and I'm ready to start actually doing some preliminary multicolor prints. So let's now take a step back and answer some of the questions that might be on all of your minds. First and foremost, how long did this take? Well, the initial build was 16 or 18 grueling hours for the 12-gate version, not including rebuilding the toolhead and converting the printer to CAN bus, which was easily another 8 hours. Then it probably took me another 20 to 30 hours of fixes, tuning, and calibration. Now my hope is that with all the tips that I've given you here in the video, you could probably cut that second number in half. But you're still looking at basically a full work week, if not more, to actually get this thing running okay. Will this work with my printer? In theory, you can put this on literally any direct drive Klipper printer that has a spare USB or CAN bus port. Ideally, you would want to have the Stealth Burner toolhead because that already has a whole ecosystem of designs that integrate a filament cutter, sensors, and all of that. But with some ingenuity and CAD work, you should be able to either design a custom solution for your existing toolhead or work around the need for a toolhead sensor or cutter altogether by tuning the tips, for example. You could also just do an encoder cutter and then you won't even need to worry about what the toolhead on the printer actually is. How much does it waste? The biggest question on most people's minds is probably going to be how much this system wastes or poops. This is one of those things that is subject to tuning, and you can get the waste down much more than I have even had time to do by fine tuning. For my part though, I will say that even though I haven't done very much of that fine tuning for waste, I'm actually already blown away by how much less this system wastes as compared to my other multicolor printers that I own. This is because, as I've alluded to a few times, you are able to tune it to retract the filament as much as possible so as to only cut off the absolute very tip, which is already melted and is good as useless anyways. Now, to give you a sense of just the proportions we're talking about, on my Bambu Lab printers, I generally actually set the flushing multiplier in OrcaSlicer to 0.7, And even then, I sometimes do get a tiny bit of bleed when going between extreme color changes. On this setup, I'm regularly setting it to 0.35, which is half as much, and it is just fine. Plus, I do think that I could actually tune it even a little bit more to cut off maybe another millimeter or half a millimeter, and the waste would be even less. So essentially, whereas on a bamboo printer, I'm using a purge tower and pooping out a ton more filament than the model itself, on this, I actually only need the purge tower, and I think that maybe, just maybe, if I had a lot of time, a lot of info, and a lot of supports on the prints, you might be able to do away with that as well. Do drop a comment below if you'd like to see a video about that in the future where I experiment with cutting the waste. How fast is it? One of the things that is really holding a lot of people back from multicolor printing besides the waste is just how much time it takes to change tools and purge. So how fast is this system? Well, here again, the disappointing answer is it depends. It's going to depend largely on how short you can get the Bowden tube, but also how fast you're going to be able to run the motor of the gear without it getting too hot or skipping steps. On my setup, with almost zero tuning and running very, very conservative numbers, I've actually already achieved swaps of 57 seconds, compared to about 2 to 2.5 minutes on my Bambu Lab X1 Carbon or P1S. Again, that's a reduction of at least 50%. But shockingly, I was actually told by Ivan, one of the beta testers on the ERCF team, that by upgrading the stepper motor and reducing the distance as much as possible that it needs to travel to get to the hot end, he's actually been able to get filament swaps down to as little as 12 seconds, which is absolutely insane to me, and which will cut the time to do multicolor prints drastically as compared with basically any other multicolor system on the market today. And as Ivan told me when we spoke, they are constantly planning further improvements to both the software and the hardware to make things generally faster and more reliable and also easier to calibrate. So there is lots of exciting stuff coming soon if you are looking to build one of these but a little intimidated by my build. And do stay tuned for that and subscribe to be notified when I hopefully do additional follow-up videos about them. How well does it actually work? Well, it's still early days for me, so I can't really comment on that personally. But I can say that I'm told by others who've put in the actual hours to tune their system that it can be highly reliable, and I have started to see that, at least the early phases of that. I've probably done 100 or more swaps at this point, and I do hope to rack up a lot more between when I'm recording this and when the video actually goes live for all of you. Dendrauen, the creator of the Blobifier, recently showed a log with over 1,200 successful swaps and 0 errors, which is really, really impressive. Personally, I'm still getting a fair amount of failures as I test and work through things, but with every failure, I am isolating and fixing the problems that are causing them as they come up, such as filament getting caught on the rep rack rollers or other things like that. In short, I think that you can get this thing to be very reliable if you upgrade the servo and spend a lot of hours tuning it, but it won't come easy. Though again, they're always working on upgrading and improving it, and Kinematic Digit did recently tease the RC2 version, which is direct drive, and there's actually a lot more coming down the pike. How does it stack up against other systems on the market? At the risk of being repetitive here, because I know some people will have skipped around using the chapters, let me really quickly address the comparison that I'm sure many people are making in their minds. How does this compare with other multicolor MMU systems out there on the market? Well, as I said before, this system with the proper amount of tuning and calibration can be both faster and less wasteful than other systems on the market. It's also a fraction of the cost of buying 3 AMS units. However, it also requires at least 40 plus hours to get working, so I don't think that the comparison is even necessarily relevant, especially since none of those other systems out there have been unlocked to work with existing non-compatible printers like Vorons, for example, though Anycubic and potentially even Creality are working on doing so. Those systems are products though, and this system is very much a project. Still, I think that there is one comparison that is worth making, and that's the one of closed source proprietary systems on the one hand, and open source, fully customizable systems like the ERCF on the other. If you want to build a 4, 8, 12, or even theoretically a 24 color changing version of the ERCF, you can. If you want to change how the filament cutting works, for example, extruding blobs instead of a purge tower, or cutting the filament at the encoder instead of the toolhead, you can. If you want to tune things so you waste almost no filament on purges, you can. If you want to put it on another printer, you can. All of these are things that you simply cannot do on any of the off-the-shelf systems out there right now. Is it worth the challenge of building one of these instead of waiting for Creality or Anycubic to actually unlock their multicolor systems? I don't know. But if you're the type of person who opted to build a Voron instead of buying a out-of-the-box printing bambu printer, then you probably will want that level of control and customizability. And also, besides 2 or 3 other up-and-coming kind of unproven multi-material systems for the Voron ecosystem that are currently in development, right now, the ERCF is kind of the only game in town. ERCF? Toolchanger? Which one is better? These days, there's more and more excitement over Toolchangers, with some exciting open source projects gaining popularity, and even I've been sucked into building one of my own. So I wanted to really quickly compare and contrast these 2 different ways of solving the same problem, though I do think that I'll eventually end up doing a whole video about this. When we talk about Toolchangers, the most exciting perk or benefit, at least to me, is the ability to print multiple materials, not just colors, materials like TPU with PLA, even if they have totally different print temperatures. Needless to say, the extremely quick tool swaps and the negligible amount of wasted material are also perks. But what most people don't think about, at least I certainly didn't until I started planning my own build, is just how expensive even a fully open source Toolchanger quickly becomes. Sure, stepper motors and fans, those aren't that expensive these days, but a high quality hot end and nozzle combination certainly can be, especially if you want to build 5 or even 7 tool heads. With the ERCF, we have the ability to print with 12 colors and build a 12 color switching system, all for as low as $160 plus the cost of filament. Though I would argue that it's closer to $200 once you upgrade the servo, which you'll need to do. This is a major cost savings over the Toolchanger project, making the ERCF much more approachable, at least from a financial perspective. And considering the limits to which people are pushing the ERCF, you can minimize the sacrifices in terms of swap times and wasted filament. Who is this for? Should you build one? As I said in my initial video, this project, and again, it is a project, not a product, it's not for everyone. This is a very advanced build, and it takes a significant amount of patience and grit just to get through it. As I finished recording the first video and uploaded it, I can't tell you how many people reached out to me and said that they'd built it and stopped building it because they were intimidated by the calibration, or they bought it, looked at the guide, and not even started building it. Honestly, this was actually more difficult than building a Voron, at least as far as the tuning and configuration go. With that said, if you are the kind of person like me that loves doing these kinds of challenging builds, and you don't just want to build another Voron because you've kind of already conquered that hill, then yeah, this is probably going to be a very fun project and a pretty fun challenge for you. But I do think that you need to come at it from the perspective of a challenge, and that way you'll have a much better time. Because if you come at it as a project that you just want to complete so that you can get to actually using it and printing with it, you're going to get pretty frustrated along the way when it doesn't just go to plan. But hey, I'd love to know what all of you think in the comments below. I do read every comment, and I try to reply to as many of them as I can. That's all for this week, but I'll see all of you on the next layer.